Okay, first couple of housekeeping items. First, I know I'm behind on these, so I'll be doing problems 61 through 75, and then going straight in to 76 through, what is it, 90? Yeah. So I should be working problem 61 through 90 today, because I am behind. And second, the sessions are no longer going to be live. There wasn't a great amount of participation on the live aspect of it anyways, and I am not able to do live sessions anymore as I have accepted a position at the county office this summer as the instructional technology coordinator for the district. Therefore, I will not be available throughout the week, and this will just be more flexible. The release date will also be changed to Friday instead of Thursday, and you are still welcome to submit questions you have prior to or after viewing our session. Okay, first, speaking of questions, I had one sent to me about problem 51 because I made a mistake. I was working it in GeoGebra graphically, and so what I didn't notice was that my x values were not counting by 1. They were counting by a half. And so when I went to do my slope, I tried to go over 2, but over 2 is, if over just 2 spaces, is really only over 1 because I'm counting by a half. So I should have gone over 2 more. If you go back and look at it, you'll see the mistake I made. So the correct answer to that one should have been y equals 1/2 x minus, I believe it was 4. Let me check. I believe that's what it is. Yes. No. Yes. Okay. So that is the correct answer to that. So if you got that and were wondering what was going on, that is what was happening. Okay. And then on problem 61. One thing I did look up between this week and last week is protocols for scientific notation. And I kind of told y'all wrong. It doesn't say to round here, so we really shouldn't be rounding. So all you're going to do is move to the space behind the nearest number, non-zero number. Count that spaces. So, and then you don't round anything. And this would be 10 to the -2 because I need to move backwards to undo it. Okay? All right. All right, number 62. Hey, now. Oh. Sorry, new program, all that. All right, 62. We are doing 9.3 times 10 to the 5th. Okay? So that's 9.3, and I want to move it 5, and a positive 5 means to the right. 1, 2, 3, 4, 5. All those empty spaces, I'm putting in zeros. So my answer is 930,000. Okay? Where is... Nope, that's not what I want. Sorry. There we go. There we go. Okay. Next is number 63. 4 times 10 to the 4th. 4, move the decimal place, which is invisible. 1, 2, 3, 4. Fill in the blanks with zeros. Answer is 40,000. All right. 64. 8.6 times 10 to the negative 1. Since this is negative, we move to the left. 1 space, so I have 0.86. Done. Number 65. And I know I'm going through these rather quickly, but honestly, I think this is kind of an easy topic, and we talked about it a lot last week. So 2.4 times 10 to the negative 2. Move the decimal place once, twice. Fill in the empty space with a 0. So it's 0.024. And by the way, these little bounces right here, that counts as showing your work. All right, number 66. Now, I will point out, you could do this one all through your calculator, but I would prefer it if you did a little bit in your head. And by in your head, I don't mean just write an answer, but following order of operations. We need to go in the parentheses first, but then we need to follow the rules for exponents. If I'm multiplying the bases, I'm going to add the exponent. So that's 2 to the 6th. If you think about PEMDAS, well, hold on. Let me do this a different way. If you think about PEMDAS, whatever you're doing to the bases, to the exponents, you do the thing right underneath it. So here I am multiplying the bases. So that means I'm going to add the exponents. Bases, exponents. Okay, 3 plus 3 is 6. Then here I am dividing the bases. So I'm going to, dividing the bases, I'm going to subtract the exponents. Okay, and you have a couple of options here. I like to just keep it positive and put it wherever the bigger number was. So I'm doing 6 minus 2 instead of 2 minus 6. All right. And then here I am raising these bases to an exponent. So I'm going to multiply the exponent. 1 raised to the 1 squared is still 1. 2 to the 4th squared is 2 to the 8th because I'm multiplying this. Okay. And then that is whatever 2 to the 8th is. Which for some reason, I think it's something, but I want to check and make sure. $2.56. I was actually not correct. All right, $2.56. All right, number 67. 2 to the 4th times 2 to the 3rd over 2 to the 4th squared times 2 to the 4th. Following PEMDAS. Parentheses first, so exponents in here, this is what I'm looking at. Everything else stays the same. This 2 to the 4th, I'm raising the base to an exponent. So that means I need to multiply my exponents. 4 times 2 is 8. Now here, on both top and bottom, I am multiplying my bases, so I'm going to add the exponents. That's 2 to the 7th over 2 to the 12th. Here I am dividing, so therefore I'm going to subtract my exponents. The larger one's on the bottom, so that's 1 over 2 to the 5th. That's 1 over 32. Number 68. Sorry, I've been kind of sick this week. 2 squared to the 0 over 4. Anything to the 0 power is 1, so this is just 1 over 4. Okay. And lastly in this section, number 69, 2 times 2 to the 4th to the 0 all over 2 squared. Again, anything to the 0 power is 1, so that's 2 times 1 over 2 squared, which is 2 over 4, which is 1/2. So the answer there is 1/2. All right, number 70. Let me see if I can get this. I'm going to need a lot of room on this one. Okay, a box contains 3 yellow socks. 4 blue socks. 1 orange sock. And 2 green socks. So this means our total of socks is 5, 6, 7, 10. 10 socks total. Okay, what is the probability that you reach into the box without picking? And pick a blue sock. So the probability of blue is 4 out of 10. Which you could write as a decimal as 0.4 or as a percent as 40%. Okay? Or you could simplify that into a fraction, 2 out of 5. This right here is considered your work. One of these 3 is your answer. Okay? This is considered your work along with this over here. Okay? Let me change that. I like the laser pointer better. Yeah. This over here is your work. This right here is your work. And one of these 3 is your answer. Okay. B, probability of a yellow sock. That is 3 out of 10, which equals 0.3 or 30%. Again, work, answer. All right, I need to delete some of this. Nope, erase the rest of it. Okay. To do this a different way. Okay. Sorry. We were on a red sock. There are no red socks. Ooh, that's too thick. So probability of a red sock is 0 out of 10, which is 0, which is 0%. Okay? Let me change my pen width a little bit. Okay. 2 blue socks if you pull out 2 at the same time. So for my first blue sock, so this is probability of blue and blue. That's a symbol for and. You could also just write the word. My first time, there's 4 out of 10. The second sock, there's only 3 out of 9. Okay, I know it says at the same time, but I can't pull out the same blue sock 2 at a time. So it's 2 different socks, and you have to treat it as if it was 2 separate pulls without replacement. Okay, so this is 12 over 90, which does reduce, simplify, because that would be 1/3. Yeah, so that's 4 over 30, which has a decimal, excuse me, is 0.13 with the 3 repeating, 13%. Okay. All right. And then a green sock and a blue sock if you pull out the same, pull them out at the same time. So that's probability of green and blue. My green is 2 out of 10. My blue is 4 out of 9 because there's one less sock once I've pulled the green one. This simplifies to 1 over 5. So this is 4 over 45, which as a decimal is 0.08 with the 8 repeating. So 0.088 and eventually a 9, which is 8.89%. Okay. And that was all of that one, right? Wow. Okay. What does absolute value mean? Look it up. Absolute value means the distance a number is from 0. This number is always positive. And as far as order of operations go, we treat it like parentheses. So you do what's inside the parentheses first, or you do what's inside the absolute value first. All right, so number 72, absolute value of 9. Well, there's nothing outside the parentheses and nothing to do inside the parentheses. How far away is 9 from 0? 9. And I can already hear it. How do you show work on that? There's no work to show. Blah, 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 blah. Yeah, okay, here's how you show work. 2 options. 1, you don't show work. You write an explanation, because that's always the option. Because 9 is 9 spaces away from 0. Work done, because you wrote an explanation. The other one is a number line. Put 0 on it, put 9 on it. 1, 2, 3, 4, 5, 6, 7, 8. And show your spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 away. Okay? Simple. Okay, next one. Absolute value of negative 23. Well, how far is negative 23 away from 0? 23. And again, your response can be because negative 23 is 23 spaces from 0. Or you can draw a number line, put 0 on it, put negative 23 on it. You don't even have to do all the little spaces in between. It's 23 spaces. Okay? That right there is courtesy of my cat. He just stepped on my screen. All right, next up. Absolute value of 0 is 0 because 0 is 0 spaces from 0. And number 75, 13 minus 29. Now, I said order of operations, so we treat these absolute values like we would parentheses. So that means we do what's inside of them first. 13 minus 29 is negative 16, I believe. I'm going to check that because for some reason I'm feeling stupid today. Yep. And how far is 16 away from 0? It is 16 away from 0. Now, the good news is that since I did an extra step, this right here is showing my work. So I don't have to write because negative 16 is 16 away from 0 because I showed my work to do these steps. Okay? Okay, these are called shared work problems. And there are a couple of ways to do this. One which, if you try to look this up, is probably the way that online is going to tell you to do it. It's not the way I like to do it, so I'm going to show you both. I'll alternate between them, and you can decide which one you like. Okay. The last three are not shared work; they are distance. So, but okay, we'll look at the first three. I'm going to work the first one the way I like to work it. Working alone, it takes Sue 13 hours to pick 40 bushels of apples. Okay, so Sue, can I make that smaller and still see it? You know what? Yeah, okay. All right. It takes Sue 13 hours to pick 40 bushels. So Sue, 13 hours, 40 bushels. I'm just going to use B for bushels. Kim can pick the same amount, which is 40 bushels, in 15 hours. I'm using these fractions like per, hours per bushel, hours per bushel. I could flip these and do bushels per hour, bushels per hour. And since these are fractions, I can use my calculator to get a decimal approximation for the bushels per hour. So Sue, 40 divided by 13, Sue, can do 3.07, 3.08, because there's a 6 after that 7, bushels per hour. And Kim, 40 divided by 15, can do 2.67 bushels per hour. So together, we just add those up. Together they can do 5.75 bushels per hour. Okay? So now I take that information and no, that's not what I want. Where's the one I want? Yes, here. Okay. So together they can do 5.75 bushels per hour. And they have 40 bushels that they want to do. Okay. So to end up with hours left alone over here, I need to cancel out bushels, which means bushels need to be on the bottom over here. So 5.75, 1 hour. 5.75 bushels in 1 hour. I can write that fraction either way. So now if I take 40 hours and divide it by 5.75, I will get the number of hours that they can do this job together, which is 6.96. So approximately 7 hours. It didn't ask us to round, so you could leave it at 6.96 hours, but if you do decide to round, that would probably be okay. And that makes sense because we would expect it to be about 7 hours because it should take them about half the time. Half of 13 is 6.5. Half of 15 is 7.5. Therefore, it should fall somewhere in that range. Okay? Let me delete all of this. And go on to the next one, which I will work the other way. Now, the reason why I like this way better, especially for you guys, is that this way is much more representative of something you'll be doing in coordinate algebra. The way I'm about to show you, you'll do a little bit, but not as much, okay? It says it takes Rob 10 hours to clean an attic. Sam cleans the same attic in 11 hours. How long would it take them if they worked together? Well, here's what we got to think about. We got to think about the whole attic as one job, one big job. And Rob is going to do part of it, and Sam is going to do part of it. And Rob, if he did it all by himself, would take 10 hours, and Sam would take 11. So Rob is doing some portion of his 10 hours, and Sam is doing some portion of his 11 hours, and together they are adding up to equal 1. So then how do we actually solve this equation? This is the reason I don't like this one. It doesn't make as much sense to me, but maybe it'll make sense to you. All right. So first thing we got to do is get rid of these fractions, which means we need a common denominator. So if I multiply this one by 11 over 11 and this one by 10 over 10, I get 11x over 110 plus 10x over 110, which equals 1. Multiply both sides by 110. I have 11x plus 10x equals 110. I have 21x equals 110. 21x equals 110. Divide both sides by 21. And again, I'm expecting my answer to be somewhere between 10 and 11. X is 5.24, rounding to the nearest hundredth. Okay? Now my way to me just makes more sense, but that's okay if it doesn't to you. But back to my way, because I'm the one who's working these problems. Working together, Natalie and Paul can pick 40 bushels of apples in 4.8 hours. Had he done it alone, it would have taken Paul 12 hours. Find out how long it would take Natalie to do alone. Okay, so together, they can do 40 bushels in 4.8 hours. And remember, I can write that the other way. 4.8 hours for 40 bushels. I can write that either way I want. I like the bushels per hour, okay? So if I take 40 and divide it by 4.8, I get that together they were doing 8.33 bushels per hour. Now, just Paul all by himself would take him 12 hours. So 40 bushels in 12 hours. 40 divided by 12 is 3.3 bushels per hour. So together they're getting 8.33 bushels per hour done. Paul by himself is only doing 3.33 of those. So to find out how much Natalie is doing, Natalie must be doing 5 bushels per hour. Okay? So how long would it take Natalie to do 40 bushels? So 40 bushels times, again, I want that bushels to cancel out, so that 5 bushels has got to be on the bottom, 1 hour on the top. It would only take her 8 hours. Okay? All right. Okay. Now for some distance problem. Jacob left Alicia's house and traveled toward the town hall. 1 hour later, Ryan left traveling 10 kilometers an hour faster in an effort to catch up to him. After 2 hours, Ryan finally caught up. Find Jacob's average speed. Okay, the biggest thing we need to remember is that distance equals rate times time. And we have 2 different distances, 2 different rates, and 2 different times. So I'm going to use distance Jacob, distance Ryan. That equals rate of Jacob times time of Jacob equals rate of Ryan times time of Ryan. Okay? All right, what do we know about these things? Well, we know that their distances were the same because they caught up. So dj equals dr just equals d. I'm going to drop the r and the j just to make this easier. Okay? And then we also know that Ryan's rate is 10 kilometers faster than Jacob's rate. And we know also that Ryan's time of Ryan, was 1 hour less than time of Jacob. So now I can plug all these things in to my Jacob equation. Sorry. Yes, to my Jacob equation. Distance equals, nope, to my Ryan equation. Distance equals rate of Jacob plus 10 times time of Jacob minus 1. Wait. Oh, missed something. We also know that Ryan's time was only 2 hours and Jacob's time was 3 hours. Okay, so I'm going to put that in. Distance equals rate of Jacob plus 10 times Ryan's time, which is 2. And also, distance equals Jacob's time, which was 3, times Jacob's rate, which is R of J. So these two things are equal. I can use the distributive property here, and I get 2RJ plus 20 equals 3RJ. Subtract 2RJ from both sides, and I get 20 equals RJ. Therefore, Jacob's average speed was 20 kilometers per hour. All right, let's do another one of those. James drove the train to the train station and back. The trip there took 4 hours, and the trip back took 5 hours. He averaged 25 miles per hour on the return trip. Find the average speed of the trip there. Again, we know the distances are equal. So his distance is going to equal his rate times time. And I'm going to use dt, rt, and tt for distance there, rate there, time there. And db, rb, tb for distance back, rate back, time back. Okay? Now, they give us a lot of this information. Well, first off, we know the distances equal the distances. So I can just get rid of the t and b on these because they're the same thing. Okay? And then it says that the trip there took 4 hours. So trip there, that's the time here, took 4 hours. And the trip back took 5 hours. Okay. He averaged 25 miles per hour on the return trip. So the rate back was 28 miles per hour. Now all that's left is setting these up to equal each other. I've got to calculate 28 times 5. Because I don't know that off the top of my head. 140. Divide both sides by 4. His rate there was 35 miles per hour. Okay. An aircraft carrier left the pier traveling east 8 hours before a fishing boat. Fishing boat traveled in the opposite direction for 4 hours, going 5 miles per hour slower than the aircraft carrier. The ships were then 380 miles apart. What was the aircraft carrier's speed? Okay, so again, distance equals rate times time, but I've got two different distances. Well, yes, two different directions because they both left from the pier. One went east and one went the opposite direction. And one was going slower, so it was longer. All right. So, again, we have the distance of the aircraft carrier equals rate of the aircraft carrier times time of the aircraft carrier. The distance of the boat equals rate of the boat times time of the boat. Okay. And then let's see, what else do we know? We know that the aircraft carrier left the pier 8 hours before a fishing boat, and the fishing boat was 4 hours. So the time of the boat was 4 hours. And the time of the aircraft carrier was 8 hours. So I can erase those and put those in. And then I also know that the rate of the boat was 5 miles per hour slower than the aircraft carrier. So the rate of the boat equals the rate of the aircraft carrier minus 5. Okay, so I can take that information and put it in here. I'm going to bring that 4 out front so that it's easier to deal with. 4 times rate of the aircraft carrier minus 5. Got that information. Sorry, I'm just trying to save space here. That's why I keep erasing, because I know I'm going to need space for this problem. Okay. Now, unlike last time, we can't just set these two equal because they're not equal. But what I do know, let me get that illustration back up here, is they're 380 miles apart at this point. Okay? So their total distance is 380. Therefore, dA plus dB is 380. So 8RA, that came from here. That's our distance of the aircraft carrier, plus, I'm going to go ahead and distribute this, 4RA minus 20. 4RA minus 20 equals 380. Like terms, so that's 12 rate of the aircraft carrier minus 20 equals 380. Add 20 to both sides. And I have run out of room. That'll work. And divide both sides by 12. And 400 divided by 12 is 33.33 miles per hour. Okay. All right. Get rid of all of this. Okay. All right. Now we are on number 82, and these should go much quicker. And I'm stopping at 90, I believe, is what I said. Yeah, 76 to 90. Okay, good. All right. Let's change to a different color. I'm getting tired of these colors. Let's do like that color. Okay. Write each as an algebraic equation or inequality. 5 less than a number cubed is 41. A number is going to be an n or an x. A number cubed is n cubed. 5 less than that is minus 5. Is means equal 41. Okay, now another way that 5 less than a number cubed, that might be a common way for you to think it's saying, but they really need to be explicit about, are we subtracting those numbers then cubing it? If they don't say it, go with this first one. If you wanted it to be like this, you'd have to say the difference between a number and 5, and then the result is cubed, is 41. Or take the difference of a number and minus, or 5 less than a number, and cube the result. You have to be really, really careful about that. So this one is not right for this one. All right, number 83. N cubed is at least 17. N cubed is at least 17. At least means that's the lowest it could be, but it could be that number. So that's greater than or equal to. At most means that's the highest it can be. So it has to be that number or less. Okay? Number 84. The sum of k and 5 is 20. Sum of k and 5 is 23. Number 85. A number cubed is no more than means that's the highest it could be. It's like at most. So no more than is less than or equal to 42. 86. A number squared is at least, that means greater than or equal to, 150. Number 87. The product of two numbers, x and y, or I could use n and m, p and q, whatever floats your boat. I'm going to use x and y, because why not? The product of two numbers is 12. And 88. 8 more than a number is at least 78. And number 89. 12 more than t is no more than 54. Okay, that's it. Okay, on these, you might be thinking, how would you show your work? And I would suggest again here just having a explanation rather than actually showing work. So on like this one, I would say because no more than means less than or equal to. Okay, or on the one that says the product, I might say because product means multiply. Okay, or the one that said sum, I'd say because sum means adding. Or just pick at least one word or phrase in there that you want to explain why you chose that. That's kind of the best I can do on this one. Because really this one there really isn't. It's one of the rare occasions where there really is not much work you can show. So, but you're going to get dinged points if you don't write something. So, write an explanation. All right, let's go on to the last one of today, which is number 90. -1 equals x plus 8. To get x by itself, I want to use inverse operations. You can make what I call a do and undo chart. What have I done to the x over here? I have added 8. So how do I undo that? I subtract 8. Do we always work down? Undo we always work up, according to order of operations. So I'm going to undo this by subtracting 8. So that's -9 equals x. X equals -9. All right, so this has been a double dose. And next week, it will just be problems 91 through 105. So 105, and it will not be live. It'll be like this, but you are welcome to send me questions either through my email, which is jbarton@paulding.edu, barton.k12.ga.us, or you can tweet at Barton Math, and I will go over any questions you had from this week, or talk specifically about questions you have for next week. All right, thanks, and have a great summer.